Right. Konnichiwa. Hajimashite. Watashi wa Swin desu. I'm not really a good Japanese speaker, so most of this talk would be in English, and there are some attributes in the slides which might be in Japanese, so that might help us out. All right, so thank you for giving me this opportunity to speak with you today. So I'll be talking on the topic what exactly is NLP. NLP stands for Natural Language Processing, as you might be able to see. And today our focus would be on seeing what exactly is NLP, where exactly is it being used, and in case you're a developer, how can you make use of NLP, and what sort of future does NLP hold for us. And I hope this would be an exciting talk. I would also be integrating Anusaaraka, which is the lab for which I work, and we would basically explore opportunities in Anusaaraka and NLP and see how it works out. All right, cool. To begin with, um, this really interesting quote from Albert Einstein explains it all. I would say you can take a minute or two to reflect upon it. So, if we're basically discussing the limitations of humans and computers. We're also discussing the advantages of humans and computers. But at the end of the day, what we're seeing is um, although there are some problems or there are some advantages, at the end of the day it's really good that we can make use of computers and humans in a really smart way. And as Albert Einstein has said, we can go beyond imagination, and it can be very powerful when we go this way. So what I feel is NLP is just a small aspect of computer science. You can go to machine learning, web development, or anything of that sort. But today I would be focusing on why you should pursue a career in NLP and what exactly it holds as a future for you. So just a brief introduction, maybe about me, maybe not. So I've been invited to speak in open source conference Hokkaido, which was a couple of months back, and that was my first talk in OSC. Then I was also invited to talk at PyCon Africa, which was this month, and Delhi. Delhi is a city in India. It is the capital of India, and here also I was invited to talk about NLP. So I would not really say this is an about me session, but this is more like talking about where exactly I've gone, spreading a word about this. And this would be my fourth session, second in Japan after Hokkaido. And yes, really pumped up for this. So we'll be discussing about Anusaaraka first. So Anusaaraka is basically it's an open source organization in India, in Hyderabad. Hyderabad is a city in India, and our main focus is to work on the machine translation of Indian languages. So what usually happens is to build a fully automatic general purpose high quality machine translation system, which is called FGHMT. It is very difficult because you have to there is no system or there is no machine translation system in the world which can translate a pair of languages. And the biggest problem is translation is a creative process. We have to interpret some information and see what sort of an audience it is for, and also see if the machine is capable or not. There are a lot of factors. So in the world until now, there is no fully automatic general purpose high quality machine translation system. And so the thing is, we are working on an Indian machine translation system. Our focus is to take one Indian language and convert it to English. But now my idea is we can do the same for Japanese language. We can take one Japanese language as an input and convert it to English. And if someone like me who does not know Japanese and knows English, I will write my input in English and I will get the Japanese output. And this would not be like Google Translator or Bing Translator, because here we are focusing more on the interpretation. So interpretation is a very good term for this. So interpretation is basically what sort of an audience it is, what is the purpose of the translation. So for someone like me, I might need usually the word good morning in Japanese has two different words or meaning for colleagues and for friends. But Google Translator does not know for whom I'm talking. So if I specify that I'm, talking about this to my boss or to my manager, then the good morning changes. And if I'm talking to my friend, this is just a small example. And the same way it goes for anything. So our focus here, at least in Anusaaraka, is to do this for Indian languages. And my focus for now is to focus on the Japanese languages, although I'm just beginning learning each language, and then we might get going and so and so. So this is a brief introduction about Anusaaraka. Now you might ask me what are some of the standard components of a machine translation system. So I hope you remember that we are working on a machine translation system. So a machine translation system it's basically, it takes an input in one language and gives it out. So for now, we'll be discussing some standard components of it. So we usually start with the word analyzer. These are the four terms which might help you out when you're working on this. So these are all called some standard components. So starting with word analyzer. So in the word analyzer, the words in the input text are first processed by something called a morphological analyzer. So its task is to identify the root, the lexical category, and other features of the word. So let's assume I say um, Japan is in East Asia. So here its task is to identify the root of the word Japan, the lexical categories of it, and what features does Japan has. Is Japan a noun or is it a pronoun? Does it signify a value? So this is what basically a word analyzer does. And it does that with the help of a morphological analyzer. And morphological analyzer, it is used to handle something called inflectional morphology. And to be very simple, it just returns as the category, like if it is a pronoun or a grammar word or anything of that sort. And in case if our word analyzer does not work, if the morphology analyzer it does not give us an answer, then compounding of words is done. So now you might ask me, what is compounding? So compounding is basically the word which is given to us, it is broken into two parts. So sometimes we have some very big words and we might not know its meaning. So in each of those parts, it is broken up, and then each word or each part of that word is analyzed. And this process goes on recursively, just like a loop, and then we try to find its category. Next, we have in Japanese, it's written local word grouper. So local word groupers. The problem with Indian languages is we have a lot of free order words. So free order words means there are some units which might occur with no meaning at all, and it is impossible to get a meaning out of those words. So what we do is we to be very simple, we just group them together, all the local words whose meaning we are not understanding, so that our machine also does not get confused, and it helps us that way. And for the Japanese audience, you might not be familiar, but there is a language called Hindi, and it is one of the most commonly widely used language in India. So what we do is we try to the local word grouping is very much in use for the Hindi language and other North Indian languages. I mean, Hindi, I would not say it's a North Indian languages, but it's a language that is predominantly used in the northern part of India. So this local word grouping is more valuable to Hindi and other Indian languages. And this might not necessarily be the case for the Japanese language, because again, there are different scripts. There is Hiragana, there is Katakana, there's Kanji, and each of those scripts perform very differently with each other. So we might not know if there are any free order words. I'm assuming there are not as of my experience, but there might be. So in this local word grouping, we just try to focus on grouping the words together, as simple as that. Next, we have mapper using bilingual dictionary. So as the word might be suggesting you, this is it's very obvious that we are working on two different languages. So we will have two different dictionaries. So let's assume I have a word, something like, some verb, something like I'm eating. So the word eating, if I want to translate it to Japanese or some other Hindi word or any Indian language word, it is supposed to look up for the meaning of that word and see if that makes sense. So that is how the bilingual dictionary comes into the picture. To be very simple, we just look into the elements in the source language and also the target language, and we basically try to see if our machine is able to make sense out of those words or not. And to be very simple, mapper using bilingual dictionaries, you have one word, you have other word in two different languages, and you try to sort of find out the meanings for those different words and see if that makes sense. And last one, it's written in Japanese. It's called word synthesizer. So what word synthesizer does is, it is the completely opposite of word analyzer. So in word analyzer, our main focus was to find the root, to find the lexical categories, and then find the features of a word. But in word synthesizer, we are given the root, the lexical categories, the features, and then we generate a word. So it's completely opposite of a word analyzer. And to be very honest, word synthesizer is a much simpler task compared to word analyzer. And without using more alternatives, we can use it with some given rules. I can explain it with the help of an example in my next slide. So to be in the end, these four components, when put together, that is how a machine translation system works. So I'm pretty sure that there would be many people who would be interested in developing a machine translation system, maybe for Japanese to Chinese or Japanese to Korean. So all of those factors are very important, and I feel that if you have knowledge of these facts, you can easily build a machine translation system on your own. Next, we would be discussing our proposed system design, because usually we work on a system design. So I'll be sharing my screen, and maybe we can work out. Is my OneNote visible?
Yes.
Okay, cool. Thank you. All right, so what I've done is I've already drawn few boxes so that it saves time for us. So this is basically a block diagram where we will discuss how the system design works. So I will try to explain it very in a very congenial manner so that it's easy to understand. So as it might be very evident, we start with the source language. After starting with the source language, because let's assume we are translating from, let's say, English to some other language, let's say Hindi or Japanese. So there is one source language that we have, but for now I would limit myself to Hindi or any North Indian languages. So we use something called a Sandhi package. A Sandhi package is actually just like how we work with different libraries in Python. This package is for the literally concepts of a language. So, what are the grammatical rules, what are the punctuations rule, and all of that. It is covered in the Sandhi package. After the source language, our first step would be to work with a morpholizer. This morpholizer is for there are different aspects. I can list them down. So we work with paradigms, we work with the lexical category of a word, and we also work with the default choices. So sometimes a user might say that especially in a language like Japanese, let's assume he wants to convert it from hiragana to English, or some other script, and he says, I do not want the kanji to change. So that's your default choice, and we need to make sure that the user's default choices are maintained as it is. And then we have, after this first step of morphalizing, we work on the next step. So in the next step, we work with something called TAM. TAM is tense aspect modulity. So as it is suggesting, we work with the tenses of a word, if it's in the present or future or past or whatever of that sort. And we also see if there is something called a case parsing data. This is a very technical term. We look for parsing information within the data. And Remember I told you about local word grouping. So we keep in mind the grouping rules. So maybe there are different grouping rules for different languages. So that is dealt in the second block. And this one is very integral. This is our third step and our main step. So just a sec. This is called a mapping block. So this is one of those integral parts where our main translation happens, and this is valid even for Google Translate or being translated. So since you know that we're converting from one language to other, does not matter which language it is. So we start off with the bilingual dictionaries, because we're dealing with, as I've already told you, we're dealing with two different languages. We will be dealing with two different dictionaries, of course. And since I'm talking about an Indian language, we would be dealing with something called a Vibhakti dictionary. This is a more of technical Indian language term. After Vibhakti, we have the TAM dictionary, something that I've already talked with you about. TAM is called tense aspect modality. We find the different modulars, different tenses involved, and we create a dictionary. There's a dictionary created for us, and we try to find out something meaningful for our mapping blocks. This would be our pretty much second last step. So we see what our target language is, if the word is making sense in the target language or not. And we also again find the details of TAM, that is a tense aspect modality. It is very important to focus on TAM because a lot of times, even if you would have translated, you would have seen that the tense of the word or the sentence is broken, and that pretty much spoils our translation. So it's very integral for us to focus on the TAM details. And then we have something called gen. This is remember that we started with the morpholizer in the beginning, so we would be using the same morpholizer here. It's called a morphological synthesizer. And so here again we have different aspects involved. So we start with the paradigms. So paradigms again can involve different types of nouns or verbs or pronouns, or when you deal with Indian languages, we have something called shastri. These are the different paradigms involved, and of course we have something called the default choices. So the thing is, it pretty much reiterates itself. This TAM here, so this TAM again here. We are dealing with morphological analysis here, so we're dealing with it again, and we're dealing with a default choice here. So we need to make sure that those default choices are maintained as it is. And when all of this is done, this pretty much gives us our output language. So this is a rough sketch of how a translation work should go. Again, I can reiterate this for you. So we start with the source language. We find its morpholizer. It involves the different aspects, and in Japanese, there would be a different package would be involved here. And then we try to work with the TAM, the case parsing and all of that. And since we're dealing with Hindi right now, so there's Vibhakti involved here, or usually in Japanese language there's different dictionary involved, and then there's in the last we try to make sense of all of it, we couple it all together, and we get the output language. So this is our basic system design for it. I will be going back to my slide now. Is my slide visible?
Yeah.
All right, thank you. All right, so that was about our system design. Now we would be now you might ask me that we have discussed a lot about machine translation system and what is NLP, because I've not really talked about NLP until now. So NLP is the 6 steps. So for the Japanese audience, I've tried adding the annotations or the subtitles as a small text here. So usually we start, there are usually 6 steps involved, although this is not foolproof, but yes, we usually say that there are 6 steps involved. So we start with the text pre-processing. Just a sec. All right. So text pre-processing, as the word might suggest. So we work with usually when we want to work, there's a lot of noise in the data. There's a lot of unwanted data that we might not want to take in. And that is when this text pre-processing comes in. So usually when you take in a lot of data, there's a lot of noise involved. So what we do is there are 3 steps involved. I've written in Japanese. They're called noise removal, lexical normalization, and object standardization. So pretty much, as the words might suggest you, noise removal, any piece of text which is not relevant to the context of the data and the end output can be specified as noise. So let's assume usually we have a lot of common used words like something called language stop words, or URLs, or links, or social media entities like mentions, hashtag, and all of that comes in our pre-processing noise removal. So we need to remove such noise. What I can do is I can show you a piece of sample code so that it becomes easier to understand. Just give me a second. All right, so this is our sample code to remove noisy words. I hope our audience has some idea in Python. So what we are doing is we are defining a list with the different noise words that we can say. Like, let's assume I'm working on some thesis research and there are a lot of is, a, this, the, and all of that. And I do not want that. So what I do is I'm defining a list, then I write a small function to remove it. I take in the words, and then I see if I find those words here, I try to remove them words out, and yes, I try to remove the noise. So if you basically try to execute this sample code, this is a, and this is a was already defined here, so blah blah blah, it got cut, and we have only this available here. So this is a small example of how this works out. After that, we have the lexical normalization. So let me give you an example. So let's assume I have the words play, player, or played, or played. So what happens is these are all words of they're basically the same words of the variation play. So the word play is a foundation, and there are different words coming up. So that's when lexical normalization comes. Any information which has multiple representations is called lexical normalization. And again, there's a small code you can write to do that. And then we have object standardization. That's again, usually when we have short words, acronyms, hashtags, that's when we use object standardization. And then we have the syntactical parsing. Syntactical parsing, we deal with something called a dependency tree. So what happens is we take in a sentence and we try to see if we can form a tree structure from it. Let me share my slide just a sec. I'm trying to paste an image, so it might take a minute or so. I'm sorry. The thing is, I wanted to make it happen in real time, but I think that's not possible. Let me see if the image comes now.
Okay.
Just a sec. I think it's not working out. All right. I'll better go to my slide back. All right. Let's not waste our time. My slide is visible, right? Condensing NLP.
Yes, I can see
Yeah.
your slide. Yeah.
All right. Okay, so basically we deal with dependency trees. So, when we have a very big sentence or a long sentence, we find what would be its root word, what would be its subtrees. Usually there are many subtrees. Usually there are 2 subtrees or something of that sort. It's given in a top-down manner. Let's assume I say I submitted my report. So the word submitted becomes the root word. In case you want to learn how this dependency tree works, there's something called Stanford NLP, Stanford parser, UC Berkeley parser. All of the United States universities have developed their own parser, and they're very much open source and are being used in research. words. So I would highly recommend you to go and play around with them. And yes, so there's a tree root word that comes in. Next we have part of speech tagging. So in part of speech tagging, pretty much every word in a sentence is associated with a part of speech. So part of speech are noun, verbs, adjectives, adverbs, etc. So what we do is we try to give each of our word in the sentence a POS tag, and that's how it basically defines the usage and function of the word in a sentence, and that makes translation easier for a machine. And then we have different sorts of mathematics and statistics involved. We have something called statistical features. We have oh, okay, I think I missed out on the entity parsing. All right, so again, we have something called an NER. It's called name entity recognition. To be very simple, we just use different names. We just want the process of detecting names and seeing if location name, company name, and all of that makes sense. And yes, that is named entity parsing, name entity recognition. Then we have something called statistical features that you see here. So if you're someone who is particularly very good in maths and not good in computer science, statistical features can make sense for you. It's usually that text data is quantified. Oh, all right, just went back. Yeah. So we were on statistical features. So so basically we deal with the numbers using different techniques. They are mentioned here in Japanese. Also I've mentioned it's called TF-IDF, and um, the second one is called count features or word embeddings. So what we do is we try to see if there are any word counts or any punctuation counts or any industry specific words. We tell our machine that there are this and this specific words, and you just try to learn them and make some good translation. Then we have word embeddings. I think I've just included a sample word here. So basically what we do is we just try to sort of represent our words as vectors. So over here I have the word Saturn has several rings. So what I do is I say that this is I would not be going to the code because there's not much time left for that. But usually, what we do is we take the text and we produce the word vectors as output. Each of the words in this sentence are given a vectors. If you're someone who is not good in maths, you can read about convolution neural networks and recurrent neural networks, CNN and RNNs, and yes, that should help you out. Next, last we have a text matching, which is one of the most integral parts of NLP. This is just an applied sort of feature of NLP. So what we do is there are different techniques. I've mentioned them in Japanese. It's called Leventesh distance, phonetic matching, and flexible string matching. Again, we will not go into the details, but to be on the upper layer, we are just writing some small functions which would find the distance between different words. And also these are some text matching techniques. So, you try to see automatic spelling correction like we have in our keyboards, our Android keyboards, or data duplication, or any sort of analysis. This is really helpful. And next, these are some important libraries for NLP. If you're someone who is just beginning to work in this domain, you can start with these libraries. There are actually a lot of libraries, but these three are the top ones. You can start something called scikit-learn in Python. So scikit-learn also has this application in machine learning. So if you're someone who's looking for NLP along with machine learning, this would be a really good match for you. And NLP has a lot of variations in machine learning. You can train a model and all of that. So that's there as well. Then we have something called NLTK. This is the #1 library for NLP. Anything from anything from dependency trees to extracting features of a word using NLP, you do that using NLTK. If you're someone who's not really into maths, not really into the statistical aspect of things, and just want to do NLP and see how machine translation works, this can be a really good option for you. Then we have something called pattern. Just like how scikit-learn is related with Python and machine learning, pattern is related with NLP and web. So if you're someone who's into web technologies and probably want to play around this, this should probably help you out. Apart from that, there are a lot of open source organizations on GitHub. Anusaaraka is one of them. There is also something called Stanford NLP, which I had mentioned before. So Stanford University's NLP Research Center has their own, a sort of in-house compiler, and it is being used by different industries in the world. So if you're someone who is not really looking to code from scratch and want to make help of some open source and make your GitHub repo, GitHub probably stars more or repositories more, you can work with Stanford NLP parser. There's also something called UC Berkeley parser. They're also dealing mostly with something on the sort of Stanford, but it's usually preferred that you work with the Stanford parser. And I think, yes, these libraries should help you out. And yes, thanks. This is all I have for now. I'm open for doubts. I think I did see a couple of doubts popping up here. Although I finished up in half an hour, but yes, if it's all right, we can do a code discussion right now.
Okay, thank you. And ジャニーさん、ご自身で質問されますか？
お任せします。
Okay, so we have several questions from in the chat box. One is
Sure.
so what preparation do we need to try the Anusaaraka? You may so maybe this is on the GitHub or somewhere else.
Okay. So they're basically asking me what preparation do they need to try out the software?
Yes.
Okay, so usually it's assumed that the language in which you would want to translate your text, you have some basic knowledge on your text, because Anusaaraka usually does not give us the interpretation correct. It might not make sense, but it's grammatically and somewhere on the lines of translating it very good in terms of its meaning. That is important. So in sort of preparation, I would say that if you try to probably have a good knowledge of a language, that should work out. And yes, Anusaaraka is on GitHub. It's with the same name I had on the first slide. And we can do open source contributions. And what is the next question? What kind of contribution do you expect? All right.
Oh,
Yes. Okay. So it's like what kind of contributions do you expect? Local users. Can you explain me what does this mean? Local users, as in the ones who are based in Japan?
Local user means just a user. If you open this software, it probably use some local users, for example, Japanese or Chinese or something. If you want to some contribution, what kind of contribution do you expecting?
Okay, so here the thing is it's developed only for the Indian languages, specifically for Hindi and North Indian languages, and not a lot of work has been done on the languages which are based outside of India. So to answer your question, if you're discussing about local users, I would say that it's based only in India. But if someone like you or someone like me who might like Japanese language want to learn around it, then I would say then we'll have to work from scratch, because not a lot of work has been done. And I think there are some institutes in Japan. I don't remember the name, but they have done some work, but it's not as extensive as this work is. So what we can do is we can do a collaboration deal. We can work on a Japanese machine translation software. What kind of contribution? Technically speaking, you should be knowing Python and a language called Clips. Clips is a programming language. Apart from that, if you have knowledge of Git, because usually Git is what open source is based on, and I think apart from that, it's good. Some technical knowledge and some language-based knowledge is good enough.
Okay, thank you.
Right, welcome.
Okay, and so several questions added the last of the chat box. One is it possible to simply translate English to and Hindi grammar? So these two, English grammar and Hindi grammar, is almost the same. So in Japan, so in Japanese, it's quite different grammar we have in English. Sorry, I did confused, but so maybe you can understand what I want to say.
Okay. So okay. It's mentioned that Hindi has a space between words. Yes, correct. Yes, Hindi has a space. English also has a space. Japanese does not have a space. So what happens is it's usually not. It would not be a problem if we include the space here, because we are dealing mostly with the words and the sentences. But I would say, since we're dealing with a whole different language, obviously we will need to work on the language and semantics. So that might be a problem. Coming to the next question, is it possible to simply translate English and Hindi grammar? Yes, that's definitely possible. I would say English to an Indian language or English to any language that's your mother tongue, that should be our focus right now. And I think, yes, it is possible to translate. Grammatically, Anusaaraka is really good. But in making sense of a word, like let's assume we usually translate, I mean, especially Japanese, we tend to translate from Japanese to English on Google Translator. So what happens is we see that the words do not generally make sense. So that's when Anusaaraka comes in. The words make sense, they're grammatically very good, but we expect the end user to have some basic knowledge or basic information about the grammatical rules, so that there is, even though there is some mistakes, it can be rectified. So yes, to answer that question, yes, it is possible.
Okay, thank you. そうですね。なんか頑張って日本語にしようかと思ったけど、ちょっと無理そうなので、後で頑張ります。だければ聞いてください。Okay, and one more thing. So, what was your demonstration you tried to show? I mean, so we still have some time. So, if you want to show some demonstration, so you can do that right now.
Oh, all right. Just give me a second then. I think that might take time, but yeah, give me a second. I think that should make sense.